What's going on, everybody? Feder here from 3D Print SOS. Welcome back to the channel. In today's video, we are going to be talking about this. This is my original Voxelab Aquila. Now, this will also work with the X2 and the C2, so if you have those machines, you'll know what I'm talking about in a few minutes here. But we're really going to be focusing on this little lovely ring of sample filament. The transparent red is what comes with every Voxelab machine. If you guys have one, then you'll know what I'm talking about. Now, this is usually spent in a few different ways. One, it usually sits in the box, like if you're like me, or if you actually use it to do the test prints, you can do two prints that come on the SD card. You can do the hook and you can do the test print. However, if some of you guys have already tried to print the toolbox in this, you'll find out that it goes about halfway and then you run out of filament. You can't print it all. So that's kind of a little challenge here, is I wanted to make something that you could use with this out of the box, from a brand new, freshly assembled machine that changed the machine in some way, and I came up with this. I'm calling this the OOTBDD, the out-of-the-box direct drive. Now, what this is it's an extruder. This is going to be mounting onto our little carriage here, and it's going to move the extruder away from the side here, a Bowden setup, to a direct drive, meaning it is going to directly drive the filament into the hot end. And there is some pros and cons to both systems. Let's talk about the cons first. The con is the unsprung weight that sits over here to the side is going to be moving to the hot end. So some people don't like slinging that weight around, although in my personal opinion and testing, I'm not finding that to be an issue whatsoever. In fact, if you look at most brand new machines that are coming out now, literally most of them are direct drive, so there's something to say there. But some of the pros, however, outweigh the cons greatly. For example, you can print all kinds of filament right away. You can print soft filament, you can print hard filament, whatever your heart desires, you'll be able to print with a direct drive, especially with this particular setup where the gearing is so close to the PTFE that feeds the system. You'll be able to print stuff like Ninja Flex, for example, so on and so forth. Some of the other things is you get to reduce your retraction, how much filament moves back and forth between the actual lines of filament. That gets reduced by quite a bit. It goes from around 4-ish on these machines to around 1-ish, which is a tremendous amount of millimeters that needs to be moved all the time, constantly. So that speeds up your print just a tiny little bit. And over time, if you're doing longer prints, that's going to be a little bit better for you. But not having that much slop in the system with this long PTFE tube that gets shortened tremendously, you're going to get slightly more accurate prints and slightly more control over your prints. So that's really what it's all about. Direct drive is definitely the way to go, and this lets you make this machine into a direct drive machine completely out of the box with no special tools, no extra hardware, and quite an easy install. You should be up and running in about 30 or so minutes. Now, the way I have this print set up, and I'll include both an STL and Gcode file for this machine, so that if you got it right out of the box or you have a stock version of this Voxelab Aquila, you can just upload this Gcode file to print this. It'll print under 2 hours with this sample filament with some left over, and you should be good to go to install this. But the whole idea here is that there's no wacky overhangs. It is a fast and easy print. More importantly, it's not that crazy to install. And I think overall, you're going to enjoy this system overall. You're not going to have to run your filament off to the side, having a grind on any levers. The filament can just go from the top straight into the direct drive. And then from there, from the gears, it goes almost directly into the hot end, and you get printing that way. So the goal for this video is to upload that Gcode onto my stock machine, show you how this thing does printing it straight out of the box. Then we're going to install it. I'll show you exactly what to do, how to get it done, and then we'll print some more things and I'll show you how it all works, and then we'll talk about it. All right, so, well, let's get into it. Alright, and there we have a pretty much perfect print. It came out really great. Make sure you take out the support material that's on the back here. I just used a pair of snips like this to do the job. You just kind of have to pick them off. Sometimes it likes to come off in one piece, sometimes it likes to come off in several pieces, but it should come off regardless. And on this particular filament, it likes to scar a bit when you snip it off or cut it off. It gets a little bit white, but it's still going to look pretty good even when you get that off. Either way, here is the things that I like to use on this. I'm going to need some snips. If you don't have these, and I know some of these machines or most of these machines don't come with them, get yourself some snips like this. I'll have a link down in the description below on just a cheap pair on Amazon. I like to use a blade to cut my PTFE tube, and I'll explain why for this particular mod, you don't need it to be exactly straight. However, you do need to make a kind of a TP, or like a V, an upside down V, or top of an A shape with the PTFE. It cuts really easily, and a sharp blade will do that in seconds. So we got our blade. And then just as far as tools, we have our screwdriver, we have our standard Allen wrenches that come with the printer, and importantly, we have this wrench that comes with the machine. We're going to need this to take off some of the nuts to get to the wheels that this whole carriage rolls on. So one of the things I did was I removed the filament when the print was done, and here's how much we have left. So still a ton. We should be able to print a benchy with this easily, maybe even several benchies to get the machine tuned to our liking. So actually the very first thing we can do to start this off is to move our filament holder to the other side. So you just kind of take off that nut that holds it and flip it right over. You don't need to move anything else. There you go. Now we have our filament spool holder ready to go. But in all seriousness, what I like to do is I like to get a towel of some sort and cover the glass bed. This is because we're going to be working over the bed, and the motor is somewhat heavy. You don't want to drop anything. It just keeps it nice and neat. So let me go ahead and get the camera up close, and we'll start taking this apart, and I'll explain everything that you need to do. Alright, so let's get started. So I have all my tools laid out. I have my towel on top of the build surface because I don't want to scratch it. So we are going to start by taking off the stepper motor here and the extruder itself. I'm not going to cut the video. We're just going to work together on this, and you can follow along if you want. So first, I'm going to take our first Allen key here, and I'm going to start undoing the lever itself. Don't forget the lever is on a spring, so it will kind of try to fight you while you take it off, but you'll persevere. Just keep undoing the bolt. Kind of have to depress it a bit with your other hand. That seems to help. I'm also going to suffer through it with the tools that the printer came with, because I'm just going to simulate as if I got this machine along with you guys out of the box, and I don't have any special tools. This is just the same as anyone else would be able to do it. Here we go, we're getting it loose now. Let's see if I can reach around here. I know I'll probably block the view a couple times here. What I'm just trying to do is get that bolt out of the lever. And we should be free now, so I'll just kind of pry up on it a bit, try to get the spring out. And there we go, we're free. So here we go. We have the lever. We'll keep this, because we're reusing this lever, we're going to keep this bolt in here, keep the spring the way it is, and I'm going to set that off to the side. Alright, let's keep going. With this same Allen bolt, we're going to have to take out this little spring tensioner bolt that's in the front of the extruder, and I'll show you what it looks like. It also has a little spring perch attached with it, but you do have to remove this bolt because it gets in the way of one of the bolts that holds the extruder down. Alright, so here is the bolt. Let me get the spring perch that kind of fell in here. So this is what they look like right there. And these pieces we're also not going to reuse because the tension is predetermined on my extruder. So we can go ahead and get the wire out of here. All right, so let's go down a size on the Allen key, and now we're going to get the bolt loose that has a taper. It's a noticeably silver color instead of black, so we can go ahead and get that out. Here we go. I'm going to set that aside. So the extruder is held on by a total of 4 bolts. One of them also holds the lever. The other one that we just took off is the one that is a different color and is tapered. And now there's 2 in the front here that are the same. So the third one here we could take out no problem. Don't have to worry about anything. But when we get to the next one, I'll show you in a couple seconds here. There you go. That one fell over. There you go. We're going to set that aside. This last one, once it lets go, this thing's going to want to drop onto your glass. So I like to hold it from the bottom and with my fingers as I undo this, and this whole extruder assembly is going to come undone, and the motor is going to want to drop. There we go. It has just released. So I'll show you in a second what we're going to end up with. I'm going to take that final bolt, set that aside. We're going to be reusing all the hardware. We have the stepper motor right here. I'm going to undo that cable. You can just pull on it gently. You might need a little wiggle. And we're going to reuse this cable. And as you can tell, so there you go, it is actually attached. And we're going to need this cable over here on the direct drive extruder. So I'll show you what to do with this cable later. Now, you have an option to reuse it, which is how I suggest. There's no problem that you can just pull this back and separate it, but you can get an extension if you really wanted to and not separate this cable. All right, so now we have our stepper motor. It's a pretty standard NEMA 17. I'm going to keep the gear where it is, but we will need to adjust that with the smallest size a little bit later. So for now, I'm going to just set it down on the glass and have it off to the side. Now we're ended up with the actual old extruder. What you want to do is depress this clip with your fingers, kind of push on them, and then slide this tubing out of here. There we go. And this is the old plastic extruder. We can just set that aside. We won't be reusing that. Now this PTFE tube we will be cutting, and I'll show you how to do that later, but for now we can just keep it the way it is and keep it out of the way. Okay, so the next step is we are going to use our Phillips screwdriver, and right between the wheels here on the metal plate there is a single Phillips screw, or well, I guess it's a screw. It's not really a bolt. It's kind of like one of those self-tapping screws, and it goes right into the plastic of the shroud. There it is. And we'll put that down. Since we're reusing the shroud, we need to keep that one handy. And there is kind of like a plastic clip over here on the left side that we'll have to kind of just push out. And this whole assembly can hang off to the side. Be careful, don't rip any of the wiring, just kind of let it sit there. All right, so the next thing we need to do, and this should be the easiest way to do it, is we are going to undo this hot end. So it should have 2 Allen bolts holding it on. All right, so it's only held by 2, so once you take them off, it is going to want to drop. So hold on to it, make sure it's not hot for some reason, make sure your printer is off. All right, there we go. We're going to kind of just set it all down, and we have our hot end here with the PTFE tube, with everything just kind of sitting here. I'm going to move it off to the side. All right, then we go up a size here, and we're going to need our wrench. On the back of the wheels here, there is a nut. You're just going to put the smaller side on here to hold it. And we're talking about the right wheel, the one all the way on the right side above where the hot end was mounted. We're going to essentially just unscrew this. All right, so once we loosen that, that is a nylon locking nut. It might be extra tight, but as you can see, the whole hot end mount kind of gets loose afterwards, and that's okay. So we just have to keep unscrewing this thing. It's kind of a long bolt. And essentially what we need here is we need to get to the spacer that's on here. So here is our nylon locking nut. I'll set that to the side. We can kind of wiggle this thing and take the wheel off. I'll show you what to do with that in a second. And then the spacer. The reason why this is important is because we're actually going to be kind of press fitting it in to our mount. So the way that this mount works is it actually gets installed onto the carriage like this. There's kind of a gap here that rests onto the actual plate, just like that. It's kind of a tight fit, and it should be. And essentially the bolt goes through here, but this hole needs to have this piece press fit in, and hopefully on your machine it's not too loose. Now if you can fit this in there, that is okay. You kind of want it to be pretty tight, like this is what's keeping everything from being loose. So the way that I like to press fit it, if you have a vise, go ahead and throw this thing in the vise, it'll be easy. But what I like to do is I'm just going to go ahead and use the hardware itself. So here's what I'm going to do. I'm going to put the bolt onto this side, just like that, onto the side of the washer. Here I'm going to go ahead and throw the wheel on it, and then we're going to put the nut here. I'm going to just screw it on there by hand. I know this is a little finicky here, but what we're just going to do is we're going to use this hardware to press fit that little bushing into the print. So I'm going to put the wrench on this nut just like that. We'll find a comfortable grip here. I know this could be tricky. There we go, just like that. That's a good way for me to hold it. And I'm just gonna go ahead and crank this, and there you go, now it's tight. And we're just gonna keep tightening this. I'm holding the wrench here with the rest of my hand. And we're just gonna crank that down until that bushing starts to kind of press fit itself into the plastic. And that way you don't need any special tools. Like I said, if you have a vise, you can go ahead and press fit that. But this is an easy way to do it, just right by your printer without going anywhere. And at some point this will, you know, hit the other side and it won't be able to go anywhere, and at that point you should be done. But for now, as you can see, nice and easy, slow. Alright, and I'll speed through this part, so see you in a second. Okay, so there you go. So as you can see now, that is all the way press fit inside. This wheel still spins nice and free, and as you can see, a part of the design, it kind of goes around the wheel so that nothing gets in the way. So now we just have to undo that nut again, and this part should be much easier, but essentially it's the same thing as putting it in, just in reverse. Now this is, like I said, a nylon locking nut, so this isn't going to come out really easy. There's still going to be some resistance on it. So take your time, just undo it and get that hardware out. Alright, there we go. I'm going to set the nut down, set my wrench down. Let's get this wheel off. Get this hardware out so I can show you what's going on here. Alright, and as you can see here, it is press fit into our little mount here. And now it should be nice and strong and hold everything without any kind of wiggling at all. So there's several things that I suggest here. One is to make sure that this hole that the PTFE tube needs to go into, it doesn't have any kind of loose filament in there, because this whole PTFE tube technically needs to go all the way in there. And sometimes on some machines, of course, this is going to be a really tight fit. On mine, for example, it grips, but it can still slide, and that's totally okay. That's not going to be a problem for this modification. If it is tight, that's okay. Just go ahead and push it down. But essentially what we're trying to do here is I'm going to kind of slide this down in here, and I'm going to try to put this on before sliding this hot end up, because this coupler is going to get in the way, and it'll be just easier not to undo the hot end any more than we already have. So get this in the area. The PTFE tube is going to be in your way, but essentially we need to get this bolt in here, and I'll just kind of flex everything out of the way. It takes a little second to kind of align everything, of course. Here, it might help if I just screw it in there. It might just align itself without me fighting with it too much. There we go, and it's going in. Let's see if I can push. There we go, it's coming through. Okay, so I'm just going to screw it in. It's going to make it easier for me, and the PTFE tube will just get right out of the way. Don't worry about it. There we go. Now, boom, and we're through. Okay, so now essentially what we need to do is get the wheel back onto that bolt, and it might take some little finagling on there. The hot end is this thing, the carriage is still waiting for that wheel, and it's still tight, but it should snap right on there just like I just did. And then we're going to go ahead and get our nut on the back end here and just put it on. There we go. And now all we need to do is take that same wrench onto that nut, our Allen key on the front here, and we need to tighten that up and get it pretty tight. There's no eccentric nut here, so we just need to tighten this nice and tight. Alright, we'll use the other side to make sure it's 100% tight. There we go. Roll it back and forth. As you can see, this is super rigid now. There's no movement in here. And what you want to do, take this time to adjust this lower eccentric nut. And I'll show you what I mean here. If I loosen this, let's see which direction mine loosens. I bet it's this way. I'll just kind of show you a worst case scenario, I guess. Let's see. Looks like on mine it's pretty tight out of the box, but here we go. So you might notice that there's some wiggle room in this carriage, and what you want to do is you want to get this wrench out and just tighten that bottom eccentric nut. You don't want to over tighten it. You want this thing to be nice and tight, but not have too much resistance. Like that might be a little bit too much. There we go. So you want it to be nice and free rolling, but you want it to not have a wiggle. Since the motor is going to be on here, you want that bottom eccentric nut to be nice and tight. Okay, so this part is complete. So let's go ahead and put our hot end up here. So we just kind of hold it up, and we find the two longer pieces of hardware that hold it in place. There we go. So I'll put one in, put the second one in. There we go. I'll kind of push the PTFE tube down just to make sure it's 100% where it needs to be. Let's get our Allen key and tighten that up. I'll kind of make sure that it's sitting straight. It's not absolutely critical that it's 100%, but 99 would be good. So I'm going to give this thing a nice tightening, make sure it's nice and tight. There we go. Okay, everything is sitting great. So this is a good time to take your razor blade and cut this thing so that it's out of your way so you can install the rest. So what I want to do is I take my razor blade, and there's these two pieces that kind of come together into like a little mountain that the PTFE goes to. I'm going to cut the PTFE tube just a little bit above that. And the reason why is because we're going to want to cut it in kind of like a V shape, and I'll kind of explain. So all this can just go to the side now. And you can always buy a different PTFE tube if you want to do Capricorn, whatever you might want. But essentially the point of this is the filament gets fed by this motor and gets clamped by this gear. And if you see like under it, there's a little kind of triangle. Essentially what this does is it puts that PTFE tube right under it, in between those gears, in kind of a triangle. So in order to get that all the way close to the gears, you have to cut that PTFE tube in that same shape, and the plastic on here guides you to cut that correctly. And the reason is it's so that filament won't escape underneath the gearing, such as TPU, so you'd be able to print really, really soft filament. Here, let me go ahead and turn this machine a bit. Alright, this should be a slightly better view of what I'm going to do. Essentially, I'm going to take this razor, and I'm going to very slowly cut this, kind of slicing this thing in the same direction as the little peak is. So right now I just kind of went along, cutting this thing back and forth in the same shape as the plastic guides you. And now I'm going to do it from this side. Hopefully I'm not too far in your way, but you're still getting a view of what I'm doing. So there you go. I'm just kind of going to go back and forth, and that's looking pretty good. I'll just touch it up. This doesn't have to be 100% accurate, but the more you take your time here, the cleaner you get these cuts, the better you are going to be off, especially for softer filament. So now I'm just kind of cleaning up those cuts. There you go. Let me take the camera off and show you a close-up of what this needs to look like. There you go. So that's what it should be like. It should follow the contours of the plastic here. Okay, so one other little tip is I like to take my little Phillips screwdriver, put it into this PTFE tube, and just ever so gently go back and forth, just to kind of open that tip up just a tiny bit, and it's going to make it a little bit easier later on. Now, I don't want to have any shavings go in there or anything like that, so if you see something that's like going in, you might want to just pick that out. But this just opens up that tip, and it's going to make it a little bit easier for you to get that filament in there in between the gears. So there you go. That's exactly what we were after there. So we can move on to the next step. Okay, the next step is to just put the motor on. And the way that you want to do this is you want this connector facing you to the outside of the machine. And be careful not to drop this. But what we're going to do is we're going to find that one silver bolt that has a taper to it. And we're going to put it all the way on the top right over here. That's the side that has that taper to it. Let's find the right Allen key. And we're just going to snug it up so that we're not holding it. There you go. I can see it threading in now. And we are threading it through the plastic there a bit, but that's okay. We're going to get to the end there, and then it's going to start actually pushing it towards. Here we go. It's actually kind of pushing through, and there we go. Now, I want to kind of get that tight, but we'll be tightening it a little later. So now what I want to do is move this gear where it needs to go. All right, so if you can see from here, these teeth need to align better with the center. So there's these little grub screws. We're going to take our little small Allen key. I'm going to go in here. I'm going to loosen those. They can be a little finicky. Take your time. You do not want to strip these. Make sure they're all the way in before you turn this. There we go. And now, as you can see, this gear is free to slide, and I'm going to put it in the center so that it is centered with the opening of that PTFE tube. And then I'm going to crank down. Oops. Where are you going? All right, there we go. I'm going to crank down the one with the flat side first. I'm going to spin it a little bit. Now let's crank down the one that's on the side. There we go. All right, so you should be good to go there. Now let's put in our other two black Allen keys. We'll do the far one first. All right, there's that one. Let's get the next one. So now we have all three of these tightened, and now we're on to the last one, which should be one size higher on our Allen key and our lever. So this one, just like putting it on, you're going to need to put in a little bit of pressure. So what I like to do is kind of get this into the extruder there, just like that, just a little bit. And then we're going to kind of push on everything. I'm going to put the spring on that little ball that gets printed. And then I'm going to kind of hold this thing down like this while tightening. Now this, you don't want to go all the way super tight because it does kind of hold the lever, as you can see. So I'm just going to kind of go a quarter of a turn outward. And the way that there's a design here is there's a place for your finger so that you can kind of squeeze this easily to put filament up and down through this thing. All right, so that should be the install. The only other thing here left here is to put our little shroud back on, and this is a good time if you have something else that you wanted, that you printed earlier or something along those lines. Now is a good time to do that. I'm just going to go ahead and use the stock one, and here we have some wire management. And what I like to do here is I have a little tiny piece of Velcro that I put through, and I kind of just shimmy it in here. You can use zip ties, whatever it is. But when we go ahead and pop this on, I like to take my wiring and move it to the left side of the mount here, just like this, where the connector is right over here. Actually, they move it into the camera. There we go. Here's where the connector is. And then when we pop this thing on, you can kind of see it'll go where it needs to go. That will pop right in like that. And while we have this here, let's go ahead and tighten it up and make it nice and tidy. Wrap it around. There we go. Nice and tidy for wiring here. It shouldn't get in the way. And we'll talk about how to route all that in a minute here. So the only thing left is your self-tapping screw that goes in between the wheels, and it's kind of a pain to put in here, so just bear with me for a second. All the angles, you know, trying to film while doing this, it's not necessarily good, but there you go. I got it into the hole. Let me go ahead and get the Phillips in there. There we go, and we're just going to tighten it up. All right, make sure that that's sitting nice and straight. All right, there we go. The only thing left to do is get power back to our extruder, and then we should be ready to re-level the bed and do some printing. So now I can remove this towel. We won't need that anymore. There's no hardware left. The only thing we have to do now is to, like I said, get this thing power. So let me go ahead and get another angle for you. All right, so now we're kind of on the back of the machine here where the wires are. And this right over here that I kind of pulled a little bit of earlier is the wire for the extruder motor, and right here is a little E, just so you know what I'm talking about. And as you can see, it's a part of the other cables. It's a part of this ribbon. Like I mentioned, you can leave this as is, and you can get an extension if you wanted to, and just zip tie it and run it back. But what I'm going to do is I'm going to keep this 100% stock, so you don't have to buy anything extra. And the way that we need to do this is we actually need to kind of unsheath this wiring here. I'm going to cut some of it, and the way to do that is I just take some scissors. I make sure I'm 100% not going to cut any wires. I'm just cutting this sheathing back, since we are not going to need it anymore. Take your time. Do not cut any of the wires. You can peel it back just so that you can see what you're doing a little bit better. And I'm just going to keep on moving this down, getting it out of the way of everything, and cutting it back because I do not want it. So there we go. We have about that much of it cut away, and we're kind of just going to have to sit it to the side here. But what that's going to let me do is it's going to let me continue to peel the extruder wire away from the other wiring. Just go slow here. Take your time and just peel it back. All right, so I'm going to just continue to cut this back, making sure 100% that I'm not cutting any wiring. The only thing I'm cutting is just this sheathing. There we go. And now we have ourselves, as long as we can, an extruder wire. One of the things I'm noticing here on my machine is these two wires are crossed. So I'm actually going to undo this motor wire real quick and this stopper end stop wire real quick. Let's see. And I'm going to go under it so that this is not in the way. And now these two wires can be together, and this one can be separate. I'll just go ahead and plug it in now while I'm here. There's one, and the other one I'll plug in when I'm back there because I can't see it from this angle. So there we go. Now we have some separate wires. This one is for the bed. This one is going to the X-axis and the X-axis stopper. We now have a separate wire going to the extruder motor labeled with our E. That's what we need to plug in. And we have the same batch of wires that we always had running to the hot end. All right, let me show you how to get the most slack out of this cable. So what we're going to do here is I have the machine up on the side here, upside down. I'm going to go ahead and cut the zip tie to get the cables out of here. And as you can see, you have much more space just right away. This thing goes to the side, but you do want to continue to cut this away, and it does go all the way into the compartment, which most of the time, at least on my personal machines that I do this on, I go ahead and remove the sheath all the way that way. But let me go ahead and pull it back like this. Make sure, once again, you're not cutting any cables. Take your time, and it should be okay for you. There we go. Made a mess, but that's okay. I'm going to continue to undo this cable. There we go. The zip tie right here would be perfect, but there you go. That gives you a ton more slack, and you should have plenty of room. And if not, like I said, you can always extend this cable, and it should be nice and easy. Let me go ahead and grab a zip tie so that we can put this back and make it nice and neat. All right. Let's flip it back down. All right, now that we're back on this side, I'm going to go ahead and plug in this little sensor that I unplugged earlier just to have better wire management. And I'm going to go ahead and run our extruder wire over to the extruder and we're going to just go ahead and plug it in. Now the reason why you want this thing facing you is simply because when this thing homes, you kind of want it to have enough space so that it doesn't get bunched up behind here, and same with going to the top. If you're going to print tall, you don't want it to get bunched up at the top. So this seems to be the best way to do it. And what I recommend is definitely zip tying these things, but also go ahead and move this thing all the way as far to the right as you can, and go ahead and see how much space you actually have to go up before any kind of wiring might be out of in the way. As you can see, it's already kind of getting tight, and it looks like this particular machine is going to be one of those. But like I said, that's where the extension cable might be a good idea if that's something that you're interested in. All right, one other thing that I'd like to do is I like to move this all the way to the right, find myself as much slack as I can in these machines before getting pulled. And we're going to put these cables right over here, just like that. And I want to take a zip tie. In my case, I have a little bit of Velcro left. I'm just going to go ahead and Velcro this wiring right over here, so that where the extruder used to be, and that way when this thing is traveling, it kind of has its own little path here with the wiring, and nothing gets in the way. There we go, all the way to the right, nothing is being pulled, should be good to go. And then our filament path should just be straight down into here. And go ahead and cut this off nice and clean. There we go, and the filament goes just right in right away, and there we go. Let me show you how that is. I just have it going straight down into the direct drive extruder right there. All right, so hardware wise, you are now all set up to enjoy your direct drive. Now keep in mind, this wire might be a little short for some people's liking. I understand. Go ahead and feel free to either get an extension or manually go ahead and extend the wires. Should be easy to do if you have any kind of experience doing that. Just keep that in mind, that is a thing with this build, that is a downside of not changing anything else, just keeping it 100% out of the box. However, you're not limited by the design on this end by going up, down, left, or right like you are on most other mounts that are out there that have the motor facing the other side. And the reason why I don't like the motor facing forward is because this whole thing becomes a giant lever with a lot of weight on the other side of the wheels. So this is the best of both worlds, at least in my opinion. Now keep in mind that your retractions in your slicer are going to have to lower. I like about 1. I think 1 seems to be the perfect setup for this gear, for this motor, at least on my setups. And I've had 3 of these things now, and they are all performing really, really well. So the only thing I change in my profiles, for example, is just to lower the retraction to 1 from around 4, which is what these things like stock. So let's go ahead and re-level the bed. Don't forget, we took off the hot end, so this thing does need to be re-leveled. I'm going to heat everything up, and I'm going to clean off the build plate again with some isopropyl alcohol, and we're going to use this filament and our brand new freshly attached direct drive to go ahead and print a benchy and see what kind of quality we get out of this direct drive. So I'll see you here in 1 second. Alright, our very first print on our freshly direct driven Voxelab Aquila. Let's go ahead and check it out together. Came right off. Alright, you tell me if you can find something wrong with this benchy. Because I know a lot of internet scientists are going to be out there saying that, hey, this doesn't have dual Z, so on and so forth. Now, keep in mind, this isn't the fastest benchy in the world. It's sub 2 hours, but it's no bamboo. However, this machine is literally a fraction of the cost, and now that it's direct driven, you can do a little bit more with it. So, please keep in mind this is a modification that you're doing to your 3D printer. Although nothing here outside of cutting the PTFE tube is permanent, everything can be turned back to how it was. Still keep in mind you're doing a modification, so do it at your own risk. I'm not necessarily responsible for damage that you might cause to your printer, but the most important thing is stop listening to the haters and have fun modifying your printer. Alright, hope you guys have enjoyed my modification, the out-of-the-box direct drive for the Voxelab Aquila. Now, I did mention in the beginning that you can use this on an X2, and the X2 specifically has a filament runout sensor. I personally don't like to use those. I always turn them off in the menu here because they are problematic. However, let me know down in the comments below if you'd like to see a sensor modification done to this so that you can have a filament runout right there on the top, and if there's enough interest, I'll go ahead and make that for you. So as always, the STL file is going to be down in the description. I'll make sure I post it on Thingiverse and Printables. I will also have a Gcode file there so that if you have a stock Voxelab Aquila X2 or C2, you'll be able to just print this mount with any filament that you want technically right out of the box. It should come out just like I had it. Alright. And that is all for me. Let me know if you liked this type of video. I have a few more of these type of ideas that I'd love to show off and teach everyone how to do. If you liked the video, please go ahead and check out the Patreon for this channel, or maybe become a member on YouTube. It directly helps me and directly helps me grow this channel. There's also a Discord setup. You're going to go ahead and find the links down in the description where you can join. There's a lot of free things in there, for anything from discount codes that are exclusive to the channel, to my profiles, to all of my machines, including the Voxelab Aquila. You can get help there. You can share prints, things along those lines. Okay, and as always, I'll see you all in the comments. Later.